Beatriz Cantata or Beatriz. I use the she pronoun series. I'm the Director of Engagement for Diversity and Inclusion. I oversee the Martin Luther King Visiting Scholars Program, and I have the honor of introducing Dr. Thomas Searles. So I have several good news to share before we begin. So our rock star, Dr. Thomas Searles, was recently tenured, and I want to say July, August, so let's congratulate him. Woohoo! Recently tenured. And just last week, woohoo again, he was awarded the inaugural National Society of Black Physics Award, and it is the Joseph Johnson III Award for Experimental Physics. Wow, we have so many things to be grateful for and congratulate. And also, I will point out that Thomas is from Georgia, and that's why we were listening to Ray Charles, and what a perfect song to choose this week. So I'm going to introduce Thomas in a different light, particularly because the MIT News wrote an article on him, and this was in November 5th. And what I'll do is shortly, I will post it on the chat function so that you can read the article about him as well. So here's an excerpt. So when Thomas was assigned a book report in the first grade, he initially had trouble choosing a topic. He really didn't like fiction books. After a bit of indecision, he chose to write his report on a book called Black Astronauts. Though he didn't realize it at that time, his journey to becoming a physicist at MIT had just begun. I looked in the book, and there was Ronald E. McNair, who happens to be an MIT alum randomly. He got his PhD here, Searles says. And it said that he was a laser physicist. So I said, well, that's what I'm going to be because I want to be an astronaut. And look where we are now, Thomas. Look where we are now. So I was so excited to say that. So Thomas graduated from Morehouse College with a BS in mathematics and physics. And he is currently an associate professor in the Department of Physics at Howard University, a historically Black college and university located in Washington. There, he established a new research program in applied and material physics. He is also the director of a new academic partnership between IBM and 13 other HBCUs called the IBM HBCU Quantum Center. I also want to acknowledge two important people in his life. So his wife, April, who's joining us today, and their dog, Shuri, if I'm pronouncing it correctly, from Black Panther. Woohoo! Okay, without further ado, I pass the mic on to Thomas.
So good morning, everyone. It's truly an honor. I guess it's afternoon technically here in Washington, D.C. But it's truly an honor to speak with you all via Zoom for my public engagement talk for the MLK visiting appointment. So let me bring it up, and as I bring it up, I'll definitely talk a little bit about how special this is. And just a note about the song, Ray Charles is from my hometown, Albany, Georgia. So that just makes it doubly good, especially with last week, the good news that came out of Georgia. So we're extremely excited to represent today. If you have any questions or want to connect, this is for those that are in the MIT community. My email address is here. But today I'd just like to give a few ideas and examples, introduce myself and what we're all about at Howard University in our lab. And throughout the story of my life, I will be giving shout outs to many of my friends and family that are signed into the Zoom today. So that's one of the good things about doing this over Zoom, is that the entire community gets to engage. So I'll start with just a question, something that we like to ask kids and really detail a report of its findings. So one thing that we typically ask young children, what do they want to be when they grow up? Which is an interesting question, and you find some really, really interesting answers. And we'll get to in a little bit of why I asked this question. And in particular, there's this imagination report that's run by the Fatherly magazine. and also New York Life. And it's very, very interesting here in 2017 that these are the top 10 popular jobs that kids of all ages came up with what they wanted to be when they grew up. So there were some kids like myself that want to grow up to be astronauts, so shout out to them. As you see in 2015 versus 2017, the athlete or the professional athlete dropped a lot of places. It was actually replaced by a doctor. And what you see for the physician is that there's a large disparity between young boys and young girls. And we'll get to the reason why in a second. And one of the other cool things that I saw from this is that at a young age, that the majority of people interested in STEM careers are young girls. So for all of those with daughters out in the audience, please encourage them to pursue science and technology. I think it's a great field. But where do kids get this idea of where they want to be when they grow up? And in particular, the top influence was from TV, YouTube, and movies. Other things like myself, I had a personal passion. I'll talk about the involvement of my parents in the school and family members a little bit later. Not so much sports and video games, but really this idea of media that the student is experiencing really influences their idea on career choice. So you can think to yourselves in 2017 or 2016, 3 years ago, what would you think would be the reason why the majority of young girls would want to be a doctor? Well, Doc McStuffins. She was extremely popular at the time, still very popular at the time. And there's the creator of Doc McStuffins, Chris Nee, with the doc herself. And in this article from The Observer in 2016, it shows the power of animation, but really the power of representation. Little young Black and brown girls saw themselves as Doc McStuffins, therefore they can grow up to one day to be Doc McStuffins. And as an aside and a side note, another thing that not only does representation matter, but HBCUs matter. In particular in building the next generation of young Black physicians, which in today's COVID world, we need more and more representation in this space. And historically, Black colleges and universities, according to this report in 2017, play a vital role in this case. Something that was shocking to me when I was looking this up was that there was something that was missing. Where are all the little kids that want to be superheroes? They're nowhere within this top 10 areas. So what about superhero X is what I'll say for superheroines also. What about the superhero? And in particular, that made me think about Black Panther. At the time, it was the third highest grossing film ever, surpassing the Titanic, Avatar, and one of the Star Wars movies. For the Black community, it was a beautiful thing to see. People dressed up in African garb and kente cloth, and they went to the movies en masse, and they had photo shoots. It was a beautiful thing to see. You should look at the internet to see that. But it's really, really transformative with respect to how Black people were seen on film, specifically in action heroes. And more importantly, before the movie, The Black Panther, there was the comic. And the comic in which Black Panther first arrived was in Fantastic Four's number 52, all the way in 1967, where Stan Lee created this character, the Black Panther, as an homage to the Black Panther Party and the movement that was going on in the 60s. The Black Panther's alter ego was King T'Challa, king of this mysterious place called Wakanda, which we'll talk a little bit about later. But for those that weren't born in the 60s, but had experiences in the 80s and 90s like myself, there used to be, before the blockbuster movie, a spin-off cartoon on television that talks about the Black Panther. And even in today's world, and to get with kids today, the Black Panther could be seen in comics. They still produce them right now. Shout out to Cursa. Hi, Cursa. I saw her in the screen. All right, awesome. So one thing, so who exactly was T'Challa? And this is extremely important, something that the comic book highlights, but the movie we'll talk about not so much. So there are certain attributes of T'Challa that were quote unquote his origin story. And the most important one that we'll talk about today is that he got his PhD in physics from Oxford University. So he left Wakanda, went to some far off land in America, studied in undergrad. In undergrad, which you'll see to the left, not only was he interested in science and studying materials, but more importantly, he was also a student athlete. And this athleticism that he honed as a student athlete also helped in enhancing his strength and his ability and his durability as the Black Panther. He was also respected by his colleagues. He was known as was one of the top 5 geniuses in the world, and was well respected by another superhero, the Hulk, who was also a physicist. And last but not least, the beauty of the Black Panther in the comic book was that a lot of these attributes that he possessed was enabled by the natural resource of his homeland. And that natural resource, which he went on to Oxford to get his PhD to study more, was actually this idea of vibranium that creates the Black Panther suit. So just a little bit about the movie, something that was missed, something that I want to point out, which is very critical, and hopefully you all can hear it. So please give me thumbs up in the chat if you can hear the video. So from the clip, we learned a lot about vibranium. We first learned that the first suit was made by T'Challa when he was over the lab. But we also learned a lot about the physical properties that make vibranium special. And in particular, we know that it was lightweight, durable, flexible. It absorbed kinetic energy, and it had the ability to switch between visible and invisible. Now, this quote unquote vibranium is a fictitious comic book type of scenario. So the physical attributes are translated into comic book talk. However, they actually correspond to real world materials that we study, not only at Howard University, but also at MIT. And in particular, the idea that it's flexible, lightweight, and durable is this idea of elasticity. So it has a high elasticity. The fact that it can absorb kinetic energy is something that we can think of as a pressure inducing an electric field, or causing electrons to move after being pressed up and down, which is a piezoelectric. The idea that it had some type of strong electron-phonon coupling comes out later in the movie. It can also be thought to be superconducting. So something that's recently happened in science in the last couple of weeks is that there was a report of a room temperature superconductor. So a lot of people are extremely excited about that. However, the caveat for that recent result is that we're not quite there yet. To gain a high temperature, room temperature superconductor, you need extremely high pressures. But however, it's something that was recently discovered. So we're extremely excited about that. And the last 2 things are something that I intimately work on, and I'll show it throughout kind of the rest of the presentation a little bit later. But this is this idea of tunable optical properties, or cloaking. Can things disappear? Can you change, in this case, T'Challa turned on by hitting a wireless sensor. He turned the suit on. He could also turn the suit off. So this is this idea of a metamaterial, something that my group has been working on for many years. And the last thing is this idea of topology, and in particular, topological materials, which are studied in Joe's lab at MIT. And these are things that are robust against damage, but they're also robust against changes such as putting holes in the materials and other things. And another beauty of all of these things is that the physical properties of the materials can be applied to many different facets of society. In Wakanda, they used the vibranium for transportation. You saw magnetic levitation trains that moved throughout the city. They also used it in fashion. Things are flexible, but also durable, but they also look good. You could also see things like electronics and photonics and those devices. And this really is the heart of what we're trying to do in my laboratory at Howard, but also kind of my experience in working in science in general, is to look at how we can harness natural resources for the betterment of society, just like in the Black Panther. Now, as I stated earlier, the Black Panther is not the only superhero physicist. You had the Incredible Hulk, for those that are huge Spider-Man fans, not Miles Morales, but the other Spider-Man, Peter Parker. Peter Parker was actually a graduate student for the majority, which those that are in graduate student school now, you can imagine trying to do graduate studies, then also fighting crime. But Peter Parker was able to do that as a graduate physics student. There you have the comic version of Shuri, which is Black Panther's little sister. So she's also a physicist. And then you have the Black Panther themselves. But we also want to note that although these are physicists, they are also superhero engineers. In particular, for all my friends and family that are at home and not that familiar, the mascot for MIT is the engineer. And here we have two superhero engineers with MIT ties and degrees. In particular, the Iron Man was classmates with Killmonger, which you'll see to the right. And Killmonger actually went on to be a professor at MIT. So I don't know if he was an MLK professor like myself, or if he was there for some time. But after he served, if you follow the comic book, after he served as King of Wakanda, he spent some time lecturing at MIT. So together with the physicists, we also have the engineers to better society. So I do want to point that out. So let's talk a little bit about my brief origin story, who I am, where I came from, and some of the materials that I study that are now vibranium-like. So here you have a photo of my dad and myself outside of my grandmother's house in Tallahassee, which we'll come back to Tallahassee many times. And as it was stated, I'm from Albany, Georgia. In the first grade, I read a book about Ron E. McNair. But in high school, there's something critical that happened. And in particular, in the state of Georgia, there was really an attack on public school education in physics. A lot of physics in the curriculum across the state of Georgia was removed. And I was very, very lucky in that my mother not only recognized the importance of physics for me personally, but the importance of what I wanted to be when I grew up and what physics meant. So she went to battle with the school board. And to this day, I'm very thankful for my mother because she went to those meetings and fought for me to have an independent study AP physics course. And I was very, very fortunate to have a mother to do that for me. And as a result, I stand here as a physicist. The other important and critical thing that I was able to do in high school was that I did 2 summers, one after freshman year and the other after sophomore year, where I went to Morehouse College and I studied in college classes under the HCOP program, which was designed for health careers. But many, many students went as teenagers to Morehouse, and it really gave me a feel of college and understanding of what it was really, really about. And then after which I was actually admitted early into Morehouse College. So I went to Morehouse at 17 under the same early admission program that Martin Luther King went when he was 15 years old to study in Atlanta at Morehouse. So that really was my start. And shout out to my two big sisters. Erin is in the chat talking to me. And then another connection with Ron McNair, a long time ago, even though my hair is similar now. I was quite the Taekwondo champion at 7 years old, as you see there. Don't ask me to do it now. It'll be a sad scenario. But this is my origin story growing up in Albany. But everything changed at Morehouse. In particular, Morehouse was a place that since the early 50s, it was a place where Black people learned physics. And this is critical and important to my story. At the time, I was there as a Ronald E. McNair Scholar. So shout out to all my Ronald E. McNair Scholars that are on the chat today. And as a part of that program, you have a cohort of 25 young men that study anywhere within STEM. Many of us went on to get higher degrees from this program that was funded by NASA. The other thing too is that there were an extreme kind of level of mentorship that I appreciated and needed at the time at Morehouse. There I'm pictured with Walter E. Massey, who is a theoretical physicist. At the time, he was a president at Morehouse College. So we call ourselves the Men of Massey. And it was just a very special time where he always made it a point to come to the physics department, talk to us about what it meant to be a physicist, talk to us about what it means to leave the comfort of Dansby Hall and to go into these spaces that are not as friendly, that we must go to, whether that's national labs, which you'll see a little bit later in my experience, or anywhere else. And again, another important part, other than forging lifelong friendships that I still use as a network for my students today, another critical part was that I was a student of the National Nanotechnology Initiative. So what that meant was that there was a wide investment in training young students in aspects of nanotechnology that really prepared me to be where I am today. In fact, the bus card that I used in 2007 is the same bus card that my students and I use today when I go to Georgia Tech to do things at Georgia Tech. So it has a vast, broader impact just from those years at Morehouse. So, like T'Challa, I then traveled to a faraway land. And that faraway land for me was Texas. And we could talk ad nauseum about how that experience was. But it was actually an extremely, it's something that I look back upon with glee. It was just a great time to be a scientist. I was able to perform experiments in Japan and the US at various government labs, essentially anywhere that there was a high magnetic field. I actually did a lot with the National High Magnetic Field Lab in Tallahassee, Florida. So if you remember the picture of my dad holding me was in Tallahassee. My grandmother still lives in Tallahassee. So I would leave the lab, like no kidding, leave the lab at 5, 6 o'clock in the morning doing experiments at the High Magnetic Field Lab. And I was able to go to church and have breakfast with my grandmother the next day. And it was it was just a reminder and a motivator to keep going in the process of graduate school. And this is my advisor, Jim Kono, really off of a picture that we're taking next to a magnet in our lab, where it's really from the press of one of the most important things that I did in graduate school, which is to demonstrate paramagnetism in metallic carbon nanotubes, which I'll talk just a little bit of science for the scientists in the group. So to the right, what you see is a graphene sheet or a hexagonal lattice arrangement of carbon atoms. And carbon nanotubes are special not only for people at Rice, where I used to say everyone speaks carbon nanotube because they were founded at Rice. So you would find people in philosophy telling you about chiral indices, which was interesting to see, but it was just pervasive amongst the campus. But one of the cool things about carbon nanotubes is that depending on how you roll the sheet, that you can have very different properties. It can be metallic, it can be semiconducting, it can be some mix between the two. And the way that you classify them is amongst this chiral vector. I promise I think this is the only equation. There might be two equations. But this chiral vector, it dictates whether it's a metal, a semiconductor, what the band gap is, how can you use the material. Again, I dealt with high magnetic fields, and here you have some theory. And in particular, you're looking at the magnetism as a function of where you are. So is the magnetic field this way? Is the magnetic field this way? Will it repel the magnetic field as far as a diamagnet, like water is one of the most famous diamagnets. But another famous diamagnet is graphite. So when you see this experiment on the internet of a frog in a magnetic field and that frog is levitating or floating, it's because the frog's body is mostly made of water. Another thing that people show all the time is this idea of a pencil lead, which is made of graphite, and it's actually floating over something or levitating. And this is because graphene itself is one of the largest diamagnets, is what we call it. However, something extremely interesting was predicted to occur when you change the wrapping of the carbon nanotubes. In particular, when the magnetic field was perpendicular, so you're going through the graphene sheet, whether it's metallic or semiconducting, is predicted to be diamagnetic. As you change the angle of the carbon nanotube, then we see a vast anisotropy or difference where the metallic nanotube turns paramagnetic or attractive. Instead of repelling, it is attractive to the magnetic field, versus a semiconducting carbon nanotube that would remain diamagnetic regardless of the angle of the field. So we were able to experimentally show this. I actually spent Thanksgiving on a magnet. I called my family and I was like, hey, how's the turkey? I felt bad that particular day. So I found the only turkey sandwich that I could find in Japan, and I ate it. But what it really did was it really set the tone where we found or showed this experimental work, which I thought was really, really special. After graduating from Rice, I actually had the profound opportunity to go back to Morehouse, which was really, really special. I actually went right back to the lab where I was trained as an undergraduate student. And it was like looking in the mirror, is how I would describe it. There were so many young men that were there that came from all over the world that now I was able to take my experiences that I learned at Rice and to bring those connections and that right back to the lab. So outside of nanotechnology, I was able to introduce terahertz spectroscopy, 2D materials, and this idea of metamaterials, which I studied a little bit more later. I mean, one of the proudest moments that I had was, here's a picture of me and some of the guys on the last MUREP, so it's a minority undergraduate research and education program at NASA. They would have zero gravity flights where we were actually able to do an experiment together at Johnson Space Center at zero gravity. So this was a really special time. However, in 2015, I got the opportunity to go to Howard University. So for those that are not familiar with Howard, we're a federally chartered institution. You can think of us as the state school for the United States. Many of the schools in the DC area started out as federally chartered institutions, but Howard and Gallaudet, which is a school for deaf and hard of hearing, are the only two institutions that still have a line item in the federal budget from the Department of Education. So we get $350 million or so a year, hopefully higher now soon, hopefully. That of taxpayer money, and that's why I bring this up, is that everyone contributes to the education of our 10,000 students at Howard University in Washington, D.C. We also have an extremely unique space in the STEM disciplines. So here what you see is that HBCUs are proven effective producers in STEM fields, where Howard really brings in the lead. Now, Howard's much bigger than Spelman, I will say that. However, we still are number one in this space. And what you see is that there are a lot of HBCUs, which we'll talk about, many of which are in my new center. But it's something that I want to point out is that Howard is special, not only because we produce undergraduates that go on to get their PhDs, but really that we've had PhD programs in the sciences since about the 60s. Not only chemistry, but also physics and other engineering fields. So you won't find that anywhere else in the world but Howard University, which is really a unique space for a young Black scientist like myself to build a laboratory. In particular, rest in peace to Chadwick Boseman, we have a mission at Howard University to provide exceptional quality in education, but also opportunities for Black students. And that has produced many notable alumni and faculty. It's truly a blessing every day to be involved at Howard University, not only in the civil rights movement, but also in entertainment. As Dr. Boseman, because he earned his doctorate that day, speaking, which is a wonderful speech. I encourage each and every one of you to go on YouTube and watch his entire commencement speech. I'm still moved by it. And entertainment, but also in science and engineering. Also, shout out to our new vice president-elect, who is a Howard alum, Senator Harris, soon to be Vice President Harris. So we're also very, very excited about that contribution of Howard University. But again, it's not just entertainment, it's not just civil rights, but it's also in the sciences. So someone that has had a profound, one of two professors in the physics department that has had a profound effect on my career at Howard that I would only hear about, but now in their position, I think that is so special of the things that they were able to do when they were there makes a huge difference. So here we have pictured Dr. Warren Henry. Dr. Warren Henry is a solid state experimental physicist that in the 50s and 60s at Howard University did work with the Naval Research Lab. And one of the plots in magnetism is in every Holliday, Resnick, and Walker book in chapter 38. And Holliday, Resnick, and Walker is a textbook for general physics where the majority of physics majors and engineering majors and math majors all take this their first and second year. And there's actually a plot of data that was taken at Thurkield Hall in the 50s in that textbook through the work of Warren Henry. Not only was he a great scientist and accomplished scientist in this space, but he also started the programs at many, many HBCUs, including at Morehouse College. So he left Howard, he did the reverse of what I did. He left Howard and went to Morehouse and started that program, which I was a benefactor of, which I think is extremely special. Okay, good. So that allowed for me to do what I did while I was there in the past 5 years. And here you have some of the accolades and things that I'm most proud of over the past 5 years at Howard. In particular, I came to Howard and there was nothing in my lab but two donated from a previous professor, one of my mentors, Dr. Walton, who left to go to Corning. So he's in the industry, but he was nice enough to leave me two optical tables in a laboratory. And I was able to then build upon this space. And in a year or so, I was able to amass through programs of the Department of Defense, Um, Lasers, I got lasers in the room. I also got graduate students and postdocs, and we were able to not only do things in metamaterials. So this is one of our papers in which we're looking at what's called slow light. So this peak that you see in the middle, this peak is induced by the individual resonators interfering with one another, which really corresponds to a change in the index of refraction, which slows light down. With this kind of second paper out of the group in terahertz metasurfaces, we're now publishing, and actually a new publication is coming out soon in this same area of experimental physics and slow light for longer wavelengths. The other thing, back to this idea of vibranium, is that this year we published in Optica the first demonstration of a flexible photonic crystal. So previously, the photonic crystals in the terahertz regime were rigid, made out of crystal substrates, so you can't necessarily, once they're made, there's no way to change the signal. But what we showed here is that as you flex the angle of that particular photonic crystal, now we're able to change or modulate the signal actively. So we're extremely excited about that. And with respect to topological materials, so in Joe's group, we grow. Actually, one of the methods is, as we like to tell the kids, the way that you make rock candy. So you can heat a solution up, and then you have the string, and then it coalesces around the string to form a crystal. So that's exactly, in a nutshell, how my graduate student that has been a visiting student at MIT for 2 years, how she grows some of the most high quality crystals in the world. And one of them is pictured right here. So shout out to Fiona and her hard work that she's doing in Joe's lab. And all of this was the basis of my career proposal. That's why it looks really nice in that way. So another inspiration, and I will hopefully close pretty soon so we can have some questions, but another inspiration is from the professor that you see right here. And this is Dr. Herman Branson. So in himself, and you can read about the life of Herman Branson. He had a very famous advisor at University of Cincinnati, but he also had really famous collaborators in the form of Linus Pauling. So he was an X-ray crystallographer, and he did a lot of early work with Linus Pauling in this way. But the other thing that is extremely critical and interesting to what I do right now today is that he was at Howard around the time that the Second World War was occurring. And he has an article which I encourage everyone to read, which is the physicist's role in the war effort, and in particular, the training of Negro physicists is the name of the paper that he published, where he went through every HBCU, every place that produces Black students in STEM, and he developed a summer program that also had a profound effect on the Black physics community, in that he would go to these places like an Albany State, or he would go to these places like a Fayetteville State in North Carolina, or a North Carolina A&T, and he would do these 6-week intensive physics programs to prepare students to go to national labs and work with respect to the war effort. So that is extremely inspiring to what I want to do today. So in a nutshell, we need more superhero physicists. And in particular, the reason why we need more superhero physicists is our idea of the National Quantum Initiative. So if you can recall, I'm a student of the National Nanotechnology Initiative. Right now, today, supported by the current administration, that there is a $1.2 billion effort through all of these different agencies to support this idea of quantum 2.0. So quantum technologies exist right now through the form of a transistor, or the MRI machine, and other things of the first quantum. that exists, but now we're looking at this second revolution of quantum, which is this idea of quantum computing or quantum computer, and there needs to be new materials for that. But more importantly, we have to have a workforce that reflects the United States population to really compete at a global scale. And then just to give you an idea that we put in $1.2 billion, the Chinese government put in $10 billion. So that is what, it's a global challenge. Not only is China involved, but every single major power that you can think of is thinking about quantum in this way. And we have to think about it also. Which brings me to our newest initiative. So I brought this problem to IBM, and IBM really stepped up to the plate. And not only are we interested in building a quantum future, but we're more importantly interested in building an open, diverse, and inclusive quantum future. And it's critical because in the last couple of weeks, there's been several papers on how do you produce a quantum scientist. And what one of the things that they say is that they want people with hands-on skills, people with experience in quantum science and information. The other thing that they said is that they only want to hire PhDs in physics. By saying that you only want to hire PhDs in physics, you're automatically reducing the pool, and that pool will look very the same. So how do we do that? And it's even worse than when I was in school. In particular, these are the numbers for bachelor's degrees to African Americans from all colleges in different disciplines. So although more Black people are going to college, this is this black line. Mind you, I graduated in 2005 from Morehouse. So this is our number. What you notice about physics is that there's a large issue that even though the numbers are all bachelor's degrees are increasing, physics has kind of stayed the same over the past 20 years, if not declined in 20 years, which is an extreme issue. We are the only demographic that this is occurring to. Inside the AIP Team Up report, which I also encourage everyone on this call to read and learn about, is that not only does it highlight the problem that we need more Black physicist superheroes, but it gives a detailed evidence-based recommendation for not only the member societies, but what individual physics departments can do, and really what everyone on this call can do to address this problem. And in particular, these are the 5 factors that really dictate or impact the fact that we need more Black physicists. The number 1 is belonging. Black physics students feel like they do not belong in the departments that they're in, which is extremely sad to me. It's something that we're actively addressing. The second one is physics identity. They do not see themselves as physicists, this was the most shocking when I read the report, because being at a place like Morehouse, being around where my president was a physicist, being around you would just walk down the street and it would be, no matter where they were from, whether it be from Detroit or LA or Trinidad or Africa, like they were just another random physics major like I was from Albany, Georgia. So this is something that I'm actively doing in classes right now, is building the physics identity of our young Black students. The third is academic support, financial support. It was disheartening when I went back to Morehouse to see the fact that you would have 4.0 students, 3.8 students majoring in physics and engineering that couldn't support their own education, would have to go home. That was unheard of for me and the people that I went to school with. So that's another major important thing. And the other thing is just the structures and institutions and change of institutions that really, to be honest, are ripe with prejudice and meritocracy and white supremacy. So these are the 5 factors in which we have to change. Also, with working with a professor at Rowan University, Dr. Tabitha Dobbins, we've also taken this team up report, and we're now in a current study with respect to Black physics students in COVID. So understanding the changes and the impact that each one of the factors that I have listed here have as a result of COVID. So next year, hopefully, if I can give another talk, we can update these actual results and what they mean. Lastly, the last plug is for the physics departments around the world. We're taking this team up report, and I'm co-chairing with Dara Norman and Arlene Knowles. How can we really make these substantial changes to physics departments to build the next generation of quantum smart physicists and superheroes? So with that, I'd like to address the questions. Thank you all so much for your time. It's been a pleasure. I am not in Cambridge for now, but I will be visiting soon. Joe Chichelski is one of my great, he's also happens to be from the blue state of Georgia, but he's also a longtime collaborator. So even if I can't make it there right away, trust me, I will be at the Institute, and I'd be more than happy to talk with everyone at MIT. So with that, I'll be around for some questions. Thank you all for your attention.
So as you talked about some of the most inspiring or influential people, I'm going to be a little messy here. But as far as who inspired kids to actually want to go into that STEM field, and I think parenting was number 2 on that list. When are we going to have a little young Searles on the way, a young Dr. Searles?
So for those that don't know, the gentleman that asked this question, he's the best man in my wedding. He's also a physicist from Morehouse and a new dad. So congratulations to Dr. Morris. We shared the laboratory together for many, many years. So he has his PhD in applied physics from Rice University. But yeah, you already know the answer.
And then I had another question, like you fleshed out some of the physical attributes from the Vibranium suit in the movie, and you know that they'll probably more than likely have another installment of Black Panther. What attributes would you like to see if you were able to kind of write some of those things in this new installment?
Yeah, most definitely. So there's 2 aspects. I really would like to see in the next couple movies. So since the passing, this was a discussion online, like what should happen since we lost Dr. Bozeman. And I really think that it would be extremely special if they could write the origin story of the Black Panther, showing his time in America when he leaves Wakanda. And he's taking those ideas and he's in these spaces that were very, very foreign and different to him, but he still has that connection back home. This idea of Sankofa, which is a Ghanaian or West African at least ideal of looking back and going back to your community. Like that's what I would like to see in the next movie, which I think is important. As far as the suit, anything that they can do with respect to quantum computing and engaging young students in the next quantum computing challenge, I think that'll be critical. And I think they can do that within this origin story movie. There should be a Killmonger movie too.
Nice.
Thank you, Dr. Morris.